I know that Sven and Milos have wanted to host this workshop for at least 6 or 7 years. They had put a bid in to please bring this workshop to Prague. So here we are. And my name is Ann Doyle. I am the counterpart in Internet 2 to Justin Trieger in Europe. And I want to introduce Justin Trieger because Justin and I go back a long, long way. Justin is with World Symphony and is really, for me and Internet 2, the true pocket of competence in the United States. Whenever somebody's new, I beg Justin to help them learn how to do these types of technologies. And he always graciously says yes. And one of the things that we asked Justin to do a few years ago is help people who are brand new to this workshop think about how to get started, what the different technologies are. And he has framed this in a really great way to help us think about it depends on what you want to do. And then you select your technology. And I think that Justin's way of thinking about this and introducing this is wonderful. So please welcome Justin Trieger for the
Thank you, everyone who's here for being part of the Overachiever group. This is obviously an optional session, and I see a lot of familiar faces. So some of you have probably heard a lot of what I'm going to say already. Feel free to interrupt me and ask questions because I think that makes for a much more engaging presentation, conversation, and I'm happy to both answer questions and kick them over to other people in the audience if I don't know the answer. And I think that's probably an important thing to establish from the beginning. We're all kind of explorers in this realm in a lot of senses, so my expertise and experience is quite different from Jesper's expertise and experience, from Milos and Sven's expertise and experience, from Tom's expertise and experience. So what we're here to do this week is to share that experience and hopefully find opportunities to share that knowledge and then hopefully establish some collaborations, etc. And I actually enjoy the fact that we're starting 15 minutes late because where I come from, in Miami, Florida, in the United States, there's this concept of Miami time. It's a very Latin American place. Everything starts mostly half an hour, 45 minutes late, so this is the absolute best way to start my presentation, is 15 minutes late. So as Anne said, I work at an organization called the New World Symphony. It is a postgraduate music academy in Miami, Florida. It's really the only institution of its kind in the country, and it's meant to be sort of a stepping stone in between when someone finishes their master's, sometimes undergraduate performance degree, before they have a full-time job in an orchestra or ensemble of some kind. They come here for up to 3 years and get to work with a variety of visiting conductors, obviously each other, instrumentalists we bring in from around the country and around the world. What you see here is the facade of our building, which was constructed in 2011. The illuminated surface is a projection surface which we simulcast a lot of our concerts on front of, and it's become kind of a cultural center of Miami. There's usually 2,000 to 3,000 people who enjoy shows outside. Here's an interior shot of the concert hall. It's a very unique space. It's meant to be entirely flexible for the different types of programming that we do. A lot of it includes what you see here, visual projection to go along with musical performances. And the room is also very configurable at the same time. The stage itself is composed of a bunch of hydraulic lifts, so you can have varying degrees of elevation between certain sections. You can drop the whole thing flat and pull all the seats back, so you have kind of just this big space for parties and gatherings and that kind of a thing. It was designed with the way that New World Symphony presents concerts in mind, which is pretty unconventional from a standard orchestra kind of operation. So the student body of New World Symphony is 87 musicians, which is the personnel it takes to fill out a professional orchestra. We get about 1,000 applicants every year. Of those 1,000 applicants, usually we have about 30 vacancies. So it's a very competitive program. The musicianship is extremely high, and that's important for another reason I'll get to. We do about 100 concert productions each year between September and May. So we're almost at the end of the season, which means I can almost go on vacation. In all of our educational programs, they're not just about performance, which is becoming increasingly more important in the US. It's about creating a well-rounded musician, someone who has opportunity beyond a traditional orchestral job, because as many of us know, those are becoming fewer and farther between. So we teach them how to not just be ensemble players, but also how to think from an entrepreneurial standpoint, how to create their own opportunities, whether it be through teaching or professional opportunities. So moving on to the tools that we're going to talk about this week, I have evaluated them, and I say I because I evaluated these tools, and what I'm going to show you now is my interpretation of how these tools behave. People can feel free to challenge me on that, but I'm breaking it into essentially these 4 different metrics. So ease of use, and I'll define them here. Basically, how difficult is it to set these things up, and then once they are set up, use them in operation. Quality, if everything is at its full capacity, how does it compare from one tool to the next? Latency, which is a thing we're going to talk about a lot this week. How long does it take the signal to get into a microphone and come out a speaker on the other end? And accessibility, how widely is the platform used? So some of these tools are really great at certain things, but it may be very difficult to find a collaborator because they're not used in a lot of places. So there are very particular definitions to these qualifications, so keep those in mind as we move forward, because your definition may be different. Here's some shots of early experiments we did in 2002 through 2006. You can tell by the rudimentary projection and big screen television that this is from a while ago. But the early experiments were intended to do the same thing we're doing today, which is teaching and performing. So on the left you have a violin lesson. I think that's not Pinchas Zuckerman. Okay, it is Pinchas Zuckerman. He's changed a lot. And on the right we have a dance performance with live musician accompaniment. We're doing a lot of these same things today with all of these tools. The first tool we're looking at is called DVTS, and I'm almost at the point where I'm going to remove this slide, or these slides, from this presentation because I don't know anyone who's still using it, which is sad for me because this is the tool that got me into this whole space. It's a very simple software application that was originally developed in Japan, and it was built around the FireWire and DV camera technology. So it was a very simple application. That window that you see is the only window there is, and normally you'd only be entering an IP address and selecting a device, a camera capture device. So it was a very useful tool based on an antiquated technology now, which is why it's falling out of favor, but I believe you can still download it and still use it for experiments should you choose to do so. And it still acts as a very good tool for assessing network health, because of the nature of the traffic it generates, but it is Windows only. Some of the good aspects of this program, because it was part of DVSpec, it didn't treat audio in any particular way, so by spec that audio is PCM digital audio at 44.1 kilohertz, which for those who don't know what that means, it's basically CD quality audio. What people conventionally understand is CD quality audio. And by the way, I forgot to do this, and I never do this, so I apologize, but to understand better who's in the audience, can I get a hand raised for engineers? Okay, and administrators? And artists. Okay, so we got pretty even distribution, so I apologize if I get anything wrong for the engineers in the house. This tool also allowed for multicast, which was a unique feature at the time, meaning that you could go from one point to many without consuming a lot of additional bandwidth. However, multicast support continues to be an issue for most networks. It's free. It was free. It still is free. Some of the downsides, obviously, DV, if you're familiar with this format, is quite slow. So it works okay for teaching. Granted, it also induces a lot of potential echo situations because we're talking about delays that are on the quarter of a second. So if you've ever tried to have a conversation with someone who has an open microphone near a speaker with something like this, you tend to start speaking, and then you hear yourself echoing back, and you hear yourself echoing back, and it's really hard to maintain any kind of line of thought. Human brains just don't work that way. It's also limited in definition, so DV spec is 720 by 480 lines of resolution, which is not what people are used to anymore. So it would disappoint most users, I believe. It has no error correction built in. It's UDP, so if you lose packets or your network is not pristine, you will see and hear it. And as I said, there's no echo cancellation. So if someone is not handling their audio production the way we would like, you will hear echoes and they will ruin your event. Next up is Conference XP. This is another group of slides that I'm thinking about removing because I don't know who's still using it. But from a historical standpoint, it's really important to talk about. This was the first really functional tool past DVTS that people were using in a similar function. It was originally a Microsoft development, after that taken over by the University of Washington. It's now open source, so if you really want to get in there and hack it, you can. It is also a Windows-only tool. Out of the box, it leverages pretty old Windows Media encoder profiles, so that's also flexible in terms of there are new codec suites that you can install, but this is all not officially supported stuff, so bear that in mind. One of the great things about this is it wasn't restricted to DV spec. You can use pretty much any professional video or audio devices for capture. So it integrates well with any kind of USB connections, I haven't tested it with any of the newer connections because I don't use it anymore, but I would imagine if the operating system can identify the device as an audio or video device, you can probably use it with this tool. One of the unique features of this was the ability to independently control the amount of compression used for the video and audio signals, which was critical in early stages because what it allowed us to do is go to, for instance, locations in Latin or Central America with limited bandwidth capacity and say, if we're doing music lessons, for instance, from my perspective, we can compress the video down to 500 kilobits, which is quite small, and leave the audio at full frequency, full bandwidth, which would be about 2 megabits if you're doing stereo. So it allowed you to independently control that and utilize whatever small amount of bandwidth you had in the way you needed to. If you need more for video, you can do that too. It also, because of the way the software is architected, it worked with these things called venue services, which are kind of like the old school chat rooms in IM services. You'd meet at a central point, which allowed for easy multi-point function. Point-to-point is still very buggy, at least the last time I loaded this stuff up. Some of the unfortunate aspects of Conference XP, as I said, it uses antiquated compression out of the box. However, you can load X264 into it. It can do 264 compression, and it does now, I think, from the most recent installation, incorporate Opus, which is actually a quite good sounding low latency compression format for audio. Because it uses antiquated compression schemes, it is high in CPU utilization. This used to be more of an issue for older computers. Nowadays, everyone has so much computational power, it's not really an issue for anything. As I said, point-to-point unicast connections are still quite buggy. Connecting, disconnecting is funky. The last official commit to the open source code was in 2015. So take that information for what it means. It's not widely used anymore. It's not widely supported. It's not widely developed. But you can do so if you want to. Maybe someone will turn it into something useful again. H323, this is something everyone here has probably used, whether or not you know it. At some point, it's traditional commercial video conferencing, for lack of a better description. What are the benefits of this? It's low bandwidth, so normally you're talking about 2 to 6 megabits, which is something you don't necessarily need a research and education network connection for. You can do this over commodity, which is unique. It's quite ubiquitous in higher education institutions, which means normally it may be in a closet somewhere, but most universities do have these devices in their facilities. It's a commercially supported solution, so most of them, unless you're using a much older device, get regular software updates for security reasons. They do also have extensive security options if that's important for your organizations. Good aspects of these, it works in contemporary resolution, which is nice, even at low bandwidths. It has internal error correction mechanisms, so even if your network is not pristine, it can accommodate for some level of packet loss without degrading the signal. Also does easy multipoint, and it can do that. Most of them can handle up to 4 or 6 connections internally on a single device. You can do more than that as well. There's separate devices called multi-conferencing units, or MCUs, which allow anywhere from dozens or hundreds of these things to connect together. So depending on your use case, if you're trying to mount a global convening of artistic performing arts activities in a single space, this is still a good solution for doing something like that. And really the killer aspect of these is normally, particularly when we're talking about Polycom devices, they have acoustic echo cancellation baked in, meaning that even if someone's audio setup on the other side creates feedback or echo issues, they have software which mitigates most of the negative effects of those. It can still cause problems sometimes when it's meant to solve them. Some things to consider on the negative side, and when I say bad about these things, these are not, bad is maybe the wrong word, it's more just some things to consider when you start using these tools. They always work best when the device you're connecting to is by the same manufacturer as the one you are using. And that is why I say that is because they all have proprietary audio formats, and they only utilize them when it's a manufacturer to manufacturer connection, like Polycom to Polycom, or Cisco to Cisco, or I don't even know, what are the other manufacturers anymore of these? Life size to life size. So if you want the best sound out of these things, they need to connect to a sympathetic device made by the same manufacturer. The other detractor from these is they are still very expensive, even though they haven't improved, in my opinion, in quality over the years. So just to frame, we actually just purchased one of the new Polycom group systems, and with trade-in of an older device, I think we paid $12,000 US, so quite expensive. As I said before, while it's also a good thing, acoustic echo cancellation can also cause artifacts and issues, particularly with soft dynamics and certain types of sounds. So, for instance, clarinet, which when it's playing a sustained tone sounds a lot like a sine wave, the acoustic echo canceller can actually interpret that as feedback and will prematurely cut off notes. So depending on what instrument you're using, can cause problems. And as I said, along with if you connect to, for instance, Polycom to Cisco, you're not only going to have not the best quality sound, but sometimes, and I've really only seen this with life size in my experience, if you're connecting to a life size unit from another device, sometimes the handshaking is weird, and you'll find that there's signal connectivity issues with video. Sometimes you can't see them, sometimes they can't see you, and you're just kind of wondering what's going on. Next up, very near and dear to the people in this room, UltraGrid. This is an excellent software application for streaming. essentially. It is platform independent, which is great. It's one of the only tools on this list that can run on basically any operating system, be it Macintosh, Linux, or Windows. It was originally developed in 2002 by some folks in this room and is maintained by some folks in this room. And I think, I might get this wrong, but I think it's relatively newer for performing arts applications. It was originally designed for actually medical education and practice because it's designed around very high resolution video streaming was the first use, primary use. And so in those situations, they had a lot of information. They had to send live camera feeds combined with data readouts from sensors and medical equipment. So they had to have this giant video window to accommodate all of that stuff. Another really great thing, much like Conference XP in the same sense, it works with commodity or commercial hardware. So most devices, if they're recognized by your operating system, will work as a capture device for UltraGrid, which is great if you already have a lot of audio infrastructure or video infrastructure in your facility. It's as simple as throwing an UltraGrid node into wherever those signals are assembled or collected. It does support up to 8K resolution, which is a unique function in this group of tools. Excellent technical support. So it is a currently developed solution. It is currently being worked on. It is maintained. We already talked about its OS compatibility, and it offers some of the best latency metrics in this group with a minimal latency of 40 milliseconds. And we'll talk about this more throughout the week, but for the uninitiated, 40 milliseconds is essentially saying someone is 40 feet away from you. So we do this simple psychological calculation of 1 millisecond to 1 physical foot of distance, just to help you frame in your mind what it's like to use something with 40 millisecond delay. So it's quite good. Some detractors, and this is constantly changing. In my experience, the most stable use of this application is through command line. It has a great help function, so it helps you build the command line strings as you're putting them together. But it is a command line operation, and I know that there's varying comfort with operating in that without a graphical user interface. However, there is now functioning, and we'll find out more later this afternoon, but they have been working on a graphical user interface specifically for Macintosh recently. So for Macintosh and Windows, it's a pretty straightforward installation process. There is one package for both. However, Linux is a little more involved because there are so many flavors of Linux. There are different flavors of UltraGrid distributions, so something to keep in mind. Depending on what you're doing, obviously if you're doing 8K video, you need a lot of bandwidth and you need a lot of processing power. So it is very flexible, very powerful, but no, it requires more of your hardware than some of the other tools that were, depending on the use. Next up, Lola. We're going to hear a lot about this tool this week too. Originally released in 2011 by the Italian Research and Education Network. It's another Windows-only tool. It offers both color and black and white video. In 2011, the user group was quite small. Claudio is going to show a slide later on today which shows that it is quite widely used now, which is great. It offers variable video resolutions. So it uses a very specific USB 3 camera set by two manufacturers primarily, Point Grey and Gemea, if I'm pronouncing that right. You can say it any way you like. But so the resolution limitations are based around two factors. One, what the cameras themselves are capable of, but also bandwidth capacity. It offers multi-channel support, just like UltraGrid. I didn't mention that, but UltraGrid can do multi-channel as well. Much like DVTS, and maybe that's where some of the inspiration came from, it is basically a one-window graphical user interface. And it was designed with musicians and teachers in mind, so that's why it's so simple when you take a look at the application itself. Simple to use in practice, maybe not so much, but at least once everything is set up operationally, it's very simple. And it also integrates with a very particular set of professional audio devices from, who's the manufacturer?
The RME ones are the good
RME.
ones, actually any ASIO, of course.
So any ASIO device or RME particular PCI cards.
That's what you get out of it.
So some things to understand about Lola. It can require as little as 20 megabits per second if you're using compression. It can demand as much as 800 megabits per second and probably more at this point, depending on how it's configured. It does not play well with any kind of security or network control functions. That's very important to understand because it's often a very complicated conversation to have with network administrators at universities to say, hey, I want to use this very high bandwidth tool without any security measures in place, but to have a perfectly functioning Lola connection, it is essential. I've been a part of many conversations like that, and there are ways around it. There's a commonly understood network configuration known as a DMZ, which is a way of creating a safe space for that box. So if you want to get into the Lola space and you're finding that you have difficulty, there's a very active user group which can help you navigate those political complexities. But just know that going into Lola, what you need is basically a network with no security provisioning whatsoever on it for it to function the way it's designed. And as I said before, it does require very specific cameras, which are fairly economical, but you can't just use any USB device. Newer on the block are what I guess we can refer to these as hardware appliances. These are two different solutions. I'm combining them because they are kind of the same. They are not the same. They are kind of the same. MVTP is another Chesnet developed solution, hardware device. Nimbra is made by a company called Net Insight, which is based somewhere in the Nordic countries, I believe. These are designed for broadcast. So the idea here is that you have a lot of professional AV infrastructure and you're basically plugging in a bunch of, in this case, SDI formatted video signals or digital AES audio signals. The power of these devices is that they are multi-channel for both video and audio, so you can do multi-channel streaming point to point, which is kind of cool. They also obviously handle multi-channel audio transmission as well. They're standalone devices, they're appliances, so once they are set up, there's no software configuration once they're set up. It's basically just turn them on and initialize the stream, which is great past the point of integration. They handle or can do very high resolution of video as well and multi-channel high resolution video. Obviously, like any of these tools, if you're doing high resolution video and multi-channel, you need a lot of bandwidth, so something else to consider. We talked about multi-channel audio support. There is some level of error correction and recovery, but by specification, they don't like to see any. So although it's not necessary like it is with Lola, best performance happens when there's no security and no impediment to traffic on the network. These are also commercial tools like H323, so they are currently supported and you can get technical support if you run into problems. And because of the complexity, for instance, we used the Nimbra at this conference last year for the first time for performance, and the initial configuration was quite difficult, but these devices are super expensive, so they normally will send out a technician if you need help to get it configured for the first time. Does anyone know? I don't know the answer to that question. I think the MVTP was something like 15,000, 20,000 euro last time I heard. Nimbras, I think, are Nimbra is 25,000? Okay. They are also ultra low latency. These are hardware encoders, so there's no compression happening in the software realm. It's all circuitry doing the compression. So they're extremely fast, if that's important to you. Some of the detractors, obviously, like we said, unless you're compressing video, which you can do, and it looks pretty good. It's hard to detect sometimes if there's compression in use. It does require substantial bandwidth, particularly if you're doing more than one channel of video. We talked about network connections and the need for them to be clean and transparent. And we just talked about pricing, so you know how expensive we're talking. BMW or Nimbra. Correct, yeah. So these devices don't operate without a sympathetic device on the other end. So the next group of slides are my assessment of these tools. And I'd love to hear competing opinions. So if you have one, please say so. But bearing in mind the definitions we talked about earlier, so ease of use was the initial hardware deployment and then operation after the fact. So how these compare, in my opinion, MVTP, Nimbra, combined with Conference XP, DVTS, are all kind of the same level of difficulty in initial configuration and then afterwards operation. Lola is rated higher here simply because once you have a working installation and you're confident in your network setup, it's basically dial a number. It's that simple. Same thing with H323. It's the same kind of thing. You turn the system on, enter an IP address, hit call, and that you're just going. UltraGrid requires a little more nuance in terms of its initial setup, and particularly in operation, depending on your partner, unless you're working with the same person all the time, in which case you establish a set of working parameters or settings, and then you can be confident it's going to work. If you're using this with a variety of partners and bouncing around constantly, it can be a little more complex. In terms of quality of the experience at full capacity, so this is with no limitations in terms of the software or hardware, this is what it can do at its maximum. MVT Nimbra, far and away, probably the highest because of the quality of what it's capable of. Lola, slightly less, only simply because it's limited to certain video resolutions at this time. Can't do 4K, can only do one video stream. And the quality of the optics of the cameras is not the same. UltraGrid is basically MVTP and software, so it actually is quite capable of high quality, both audio and video, up to the same resolutions. H323 is limited to HD, so high quality video, it's compressed, but the audio, while the proprietary codecs sound quite good, it's still compressed audio. So you will lose dynamics, you will lose frequency range. It's good, but it's a very particular use case. Conference XP kind of falls in the same realm simply because it relies on compression, good compression in the Opus codec, but it's still compressed audio. And then DVTS, very limited video resolution, uncompressed audio. So if that's the primary use you need or primary concern, you could still use it. It would give you a good experience. Latency, we talked about MVTP, Nimbra, the hardware appliance have very low encode latencies because they are hardware-based encoders. Lola is really the killer aspect of Lola is the latency measurements. So they've been able to get encode latency, even though it's a software application, down to about 1 to 3 milliseconds, 3 to 5 milliseconds. It depends on resolution and obviously the capacity of your computer, but very fast for a software solution. In UltraGrid, with a minimum latency of 40 milliseconds, falls slightly below that, and then it gets much worse with these other tools. So maybe an important distinction to make at this point, particularly in regard to latency, is the first 3 tools are used quite commonly in live performance because of their latency metrics. The tools that follow are more for teaching, or have been previously used more for teaching. Accessibility. So I only know a few people who have MVTPs and NIMBRAs. That about says it. Lola is actually quite accessible these days. There's probably a few dozen places in the US that are equipped. In Europe, I think it's quite broadly used at this point. Most major capitals probably have at least a university capable of hosting a Lola connection, if not already a node, a working, functioning node. UltraGrid is also quite accessible. It's used very broadly in the performing arts community these days, and in, as I said before, medical education programs. So you can find people if you want to partner with someone. H323 wins here simply because it's a communication standard that's been widely adopted by higher education. So you can, as I said before, find one of these devices in almost any college or university around the world. Converse XP is not really used, DVTS not really used, which is sad but true. And then this last measurement, or graph, whatever you want to call it, is meant to confuse. Because what we just talked about is my perspective of these tools and where I see their pros and cons. And as you can see, no one tool wins any of these categories. It's a very mixed bag. So what Anne was talking about before is understanding what your use case is and what the needs of that use case are versus, oh, I want to use UltraGrid because it does 8K video. You need to first look at the activity you're trying to produce, trying to accomplish. If it's an educational exchange, if it's just a class, maybe your life would be easier if you just went with H323 because it has echo cancellation, requires lower bandwidth, you don't need these super transparent networks for it to operate. It does a pretty good job with audio, so if that's the measurement or the need that you have, then you identify the tool that best meets that need, not just a tool for the sake of using the tool. If you have something that requires immediacy, if it's a live performance between 3 locations, well, you're probably looking at UltraGrid because to date, Lola doesn't have an official multi-point support. And the MVTP NIMBRA assist solutions, you may have one partner and they may be capable of multi-point, but finding 2 functioning partners who have the hardware on hand is going to be exceptionally difficult. So one consideration in favor of UltraGrid, if that's what your use case is. If you're just broadcasting, if you're taking a highly produced concert program and distributing it somewhere, maybe you want to use UltraGrid if you're going to be doing it to multi-point, or you want to put it up as a multicast for people to tune into over the network. If you're transporting it to be projected in a large venue outside, then maybe you want to consider MVTP or NIMBRA because those are very stable tools that are designed for broadcast. So I hope that makes it clear what I'm talking about is defining the needs of what you're trying to do before you even look at the technology, because that will guide you as you look at each of these tools. And then if your tool is DVTS, I don't know what to tell you. Go back to the drawing board. Some of the challenges that still exist for all of these tools, they're too expensive. So even in the case of UltraGrid's probably the most accessible from a cost standpoint in terms of the contemporary tools, because most people have the required devices and the software is free and it runs on any operating system. So the barrier to entry from a cost standpoint is quite low. Lola is also quite low, although because it requires particular hardware, video capture and audio capture devices, there still is a baked-in cost of something like $1,200 for just the devices themselves, plus a PC that's capable of running the application. But then the MVTP NIMBRA and even the H323 are economically very expensive. Each of these tools is powerful in their own right and has strengths and weaknesses, but none of them is a turnkey solution. And if anyone says they are, I will argue them to the sun goes down. So you necessarily must have some level, and it doesn't necessarily need to be a lot of understanding of audio and video production, but you need staff or personnel who do understand general production elements and how to maximize them if you want the most out of these situations. One thing particularly in the situation of LoLa, UltraGrid, MVTP, if you're doing a really time-sensitive production, if it's a live performance between one or many sites, there's still an issue with optical networks and their ability to transmit data from one place to another. They often are the largest latency injection in the entire process. So there's a real issue with network equipment manufacturers and their ability to keep up with the software and hardware tools and the speeds they can operate with. A big one, particularly with LoLa, and it's so subtle, it's really hard to see. I think I have a demonstration later on that you can get a sense for this. But because we're talking about delays of 3 to 40 milliseconds, any additional delay induced into that equation can create communication problems, and I mean human communication problems. So most display technologies are very slow. In fact, some of even the fastest LCD gaming monitors have latencies of something like 12 milliseconds at the lowest end, which is a lot when we're talking about a 40 to 50 millisecond range of time for the feeling of real-time immediacy. So that's almost a quarter of that range that we're talking about. So there's no perfect display solution yet that is fast enough that it doesn't cause real problems. Except for CRT TVs. So if you still have a big screen TV, pull it out of the closet. And for all of these solutions, because of the bandwidths and the network conditions they require, they're still tethered to a wall. They all require either Ethernet or optical fiber to operate. Maybe that's going to change with 5G, but 5G is like a catch-all term right now for something very non-specific, so I don't know any more about that. Maybe one of you do. The next few slides are just some screen captures from projects that leverage these technologies. The Infinite Bridge was a performance done at the Royal College of Music in 2015, as part of this workshop. It involved musicians from, I think, was it Royal Danish Academy? And a few places throughout Europe, all meeting in one space in London. Near in the Distance is a series of performances produced by the Austrian Research and Education Network, ACONET. And these are some really compelling, from a visual standpoint, productions. They utilize UltraGrid for video streaming, and then LoLa is typically used for musical contributions for outside. So they actually, because of the needs of their production, combine these technologies together for different purposes. And there's videos, if you want to look up this stuff, the Near and the Distance series, there's videos of all these performances online, and they're very educational. Global Audition Training Project is an initiative we are a part of, and this is using H.323 simply because of that accessibility we talked about earlier. So the idea here is that 4 or 5 universities around the world would gather and look at orchestral repertoire and the audition process and understand through all of the different partners the cultural nuance in the audition process and approach to music in all these various places. Because as we talked about, orchestral auditions are very hard to find these days, and so a lot of people are looking at it from a global perspective, and classical music has very strong traditions in certain parts of the world, so it is a benefit to the participants to understand those cultural nuances from place to place. So that's a screen capture of a multi-point. This is a performance from 2016's NPAPW in Miami. We had utilized Lola to connect a site in Detroit, Michigan to our venue in Miami for live music exchange, but also a dance cipher, which is a breakdancing terminology, which is basically a dance circle. And there's two different varying styles of breakdancing in Miami and in Detroit, so it was kind of an exchange of those cultural ideas.
What's that word you used? A dance?
Cipher?
Cipher.
Mm-hmm. Yeah, if you see a bunch of guys, I think it's C-Y-P-H-E-R. But if you see a bunch of guys breakdancing in public and they get around in a circle and people take turns, that's what we're talking about. That was fun. So what's next? We've talked a lot about streaming technology. We're going to talk about how we get out of the box and out of the screen now. And this is where New World's focus is, the focus for a lot of you, actually. So Royal Shakespeare Company recently partnered with, as a pilot project for Magic Leap, which, if no one knows what Magic Leap is, it's an augmented reality company that's keeps talking about how great their solution is. We still haven't really seen it, but they did an initial partnership with Royal Shakespeare Company to use their goggles to add basically animated scenery to live performances. I haven't seen it, but I heard it was really cool. This is a screenshot. This is a concert that happened at New World Symphony. So one of the, let me see if this works. One of the areas we've more recently gotten into is 360 and immersive medias. And so we'll see if we can play a small sample of this. Oh, you guys are seeing the slide. I will send you all a link later. We don't have to watch this now. But because of the configuration of our concert hall and the way it's designed to utilize 360 projection, it makes for a lot of cool opportunities for placing of 360 cameras in context in an ensemble. So this is basically just a rectangular representation of that 360 video and what it looks like. But this is, for us, a really unique way of providing not an educational experience for our players, but more of an experiential thing for our audience members that is unique and provides them provides them an opportunity to see these things from a perspective that otherwise they would not be able to. Some of them are archived. Some of them are published on Facebook just so that audience can. It's the platform where everybody is, so it's easily accessible for lots of people. But these are mainly experiments right now. They're not used in any formal way. It's just we see the power of what they can do, and then the obvious interest from the general public is quite high. 360 is a little bit of a scary place, though, because traditionally in video production, the role of the director is to very concretely tell you what you're supposed to be looking at any given moment, and when you turn over that power to audience members, sometimes they don't know what to do. So that's why it works best in a situation where there's something of visual interest in every direction, because otherwise people actually often are looking for some kind of direction in terms of what they're supposed to be focusing on. So it is very powerful in certain instances. This is a HoloLens application. It's called Music Everywhere. We are very interested personally at New World Symphony for how augmented reality solutions are going to impact music education. So this is just one variation of how that might look with illuminated piano keys and some kind of animated music video playing on top of the piano for some reason. The next big thing for our space and interactive connections for education performance is three-dimensional audio. And while these technologies have been around for decades in some cases, maybe even longer than that in other cases, their use in live streaming has not been so prevalent. But to go with this 360 360 video applications, it's a natural step to then go to three-dimensional audio, because when you pair the two, it's a quite powerful experience. So ambisonics and binaural audio are two technologies we use in combination with 360 video to create truly immersive audience experiences. This is a really goofy picture from my alma mater, no less. Another really interesting frontier of 3D audio is this idea of synthesized acoustics. And so what you see here is a guy who's getting his HRTF, head resonance transfer function, which basically means how does sound react with your head? And the challenge in this space right now is that everyone's HRTF is different. And how do we create a way to synthesize these things on the fly so that everyone can have like a truly immersive experience? Like when they're watching a 360 video and they turn their head, they want to hear the audio perspective shift with that. So that's a hot topic these days. And last, we've talked about this quite often at these conferences. This is a haptic transfer glove. So this is meant to actually transfer the sensation of heat or touch across a network. And for us in performance or musical performance, that's actually quite important, because a lot of the instruction requires physical adjustment of players. So either grabbing people's hands or their individual fingers, or if you're in the case of singers, actually feeling their throats as they're singing. So this is one thing that we still haven't accomplished, but it's on the fringe for sure. And that's it for this part of my presentation. If there's any questions, I will happily try to answer them. Otherwise, maybe we can take a quick 5-minute break and we'll come back and talk about audio, video, and lighting production, which is a real geeky subject, but we can talk about it. Yeah.
Question, Justin. So, what technology do you use most at New World for the master class? And I asked that, it's a little bit of a loaded question. I recently, about a month ago, experimented with something, and it was a Bluetooth device, and a certain ensemble played, and they managed it pretty loud, and it's just completely cut off.
Yeah.
I couldn't actually hear it.
So that's a good question because it ties into the next subject quite well. For New World, it's at this point pretty equal between Lola and H323. It's just and people who have not used Lola before, you'll experience the first time you do use it. It's that the immediacy of full frequency uncompressed audio just feels so much better. It just feels good walking into the room. You feel like you're that much closer to the person, that even though the technical complexity of it is higher, you want to go that far. So the way that New World addresses or tries to figure this out is we work with a pre-established set of partners most of the time, and that allows us to keep pushing the technology a little bit further. So whereas we may work with Royal College of Music for the first year with H323 devices because they're easy and we both have them, then the next year it builds a relationship that allows us to say, okay, now that we've done this, let's move on to Lola. But it's about an equal split between the two.
It's not instrument dependent on what you use.
Any other questions? Okay, how about we take a 5-minute bathroom break and we'll come back for the fastest educational instruction on audio, video, and production, which takes a full 3 or 4 year degree in most educational institutions. We're going to cover in 30 minutes. Okay, we're going to go ahead and dive into this next section, and I'm going to sit down unless I get really excited, and then I'll stand up. So audio, video, and lighting. What we're going to talk about in regards to these are not comprehensive. These are just tips, more or less, and observations that I also pilfered from Jesper Anderson's presentation from last year, so don't worry, I trademarked everything that I think I stole. So the first thing to consider is sound philosophy when you're talking about an interactive activity. If you will rely on other people's help to produce these events, particularly audio engineers, and when you go into an audio engineer's office and you say, I want to have an interactive online lesson, they go, okay, I know just the tool for that, and they're going to set up microphones that look like this, which can work depending on what you're doing, but they can also induce a lot of echo and audio problems. The natural inclination for an audio engineer is to consider every situation as if it's a recording environment. So the idea is, how do I use the most detailed, the most clean, transparent microphones to capture the true essence of what's happening in the room? And sometimes you don't really want to do that. Sometimes you want to create an environment more like this one, even for classical music. Because what you're essentially doing every time you place a microphone in front of a speaker is creating a live sound environment. And so a lot of the principles that come into this space, we borrow from live sound production, because you have a lot of speakers in close proximity to microphones, and it takes a good deal of understanding to know how to make that work without causing feedback and other types of issues. Generally, though, there are some pretty simple principles that one can follow to get to the right starting point. So the first consideration when approaching one of these activities is, what is the use case? How are we going to attack this problem? And so the first question that we normally ask ourselves is, what kind of microphone am I going to use? And those generally fit into two categories, either a condenser or a microphone that's fed electricity, or a dynamic microphone, which is a only physical mechanism for capturing sound in the form of voltage. And then beyond that, there's what's known as polar pickup pattern, which basically says, where's the microphone listening? The next consideration is, where do we put that microphone? Do we want it near to the performer or the instrument? Do we want it far away so that we can hear more of the acoustic of the room, or the blend of the instruments? This is a consideration, and there's not a right answer for really any of these. These are just ways to think about each of these topics. Microphone technique. Do we want stereo representation? Do we want physical dimension or space in our recording? Or is it a teaching situation and it's more important that we hear clearly the instrument intonation or the voice intonation, and maybe we care more about the physical sounds that the instrument or the voice are making than whether or not it sounds pleasing? Another consideration to make. Or if we're being really adventurous, do we want to attempt surround or involve streaming of ambisonics, either synthetic or actual ambisonic recording? Obviously, if you're creating a field of speakers to recreate a three-dimensional space, you're also creating a three-dimensional feedback field. So all things to weigh, including the function. Is this a microphone or microphone array intended for the music that we're capturing? Is it for the people who are participating to speak? Because they're not necessarily, you can't always use one for both. So a little closer look at dynamic microphones. As I said before, it's usually a diaphragm or a coil that physically moves. It is disturbed by by airwaves that sound generates, and then that is translated into small electrical charges That's fed into a preamplifier so that those signals become audible, and then we work with them inside of a mixing console, and that's the general signal flow. Everyone has seen one of these. This is your basic dynamic microphone, the Shure SM58. Everybody has one. I'm sure your institution has one too. They are actually quite good at most things, particularly in this type of an environment, because of their physical characteristics and their natural ability to reject audio that's coming from off-axis, meaning pointed at the back of the microphone, not at the front. Condenser, the audio engineer's favorite for most situations. These use an electrically charged capacitor or a plate, a diaphragm, that also works with vibrations caused by airwaves and converts it into electrical energy. It typically produces a stronger signal, so these microphones tend to be much more detailed, which is great because you can hear more nuance in the actual sound you're capturing, but you can also hear echoes way better, and you pick up speakers playback way better. This is a very common microphone used in classical recording. This is a condenser microphone made by a manufacturer by the name of Sheps. Very typical to see these hanging above an ensemble. Final type of microphone. These are less common, but still pretty conventional in audio production situations. Is a ribbon microphone, which is basically a piece of metal that's suspended by two magnets. The microphone measures the variation between those two magnets as the ribbon is displaced and converts it to electrical energy. And these, because they typically are a film, a rectangular film, they tend to have pickup sound from the front and the back. So if you've seen, these were originally used a lot in radio production, and they had the added benefit of if you had a speaker on either side, you could use a single microphone and comfortably look at each other and speak at the same time. Good for some applications. They have a very characteristic sound. But again, most of the time when we're talking about interactive activities, you don't necessarily want to be hearing the back of the microphone, because that's normally where you would place your speaker for playback of the far side audio. This is a very common ribbon microphone that you've probably seen before. Polar patterns, I threw that term out earlier as basically where the microphone is hearing sound from. There are all kinds of great YouTube videos which help you understand what this means in the real world. Basically, someone sets up a microphone of a varying type that's listed here and then starts speaking and walks around the microphone, and you can hear how the sound rises in volume and lowers in volume. It's just a good way to really quickly understand how pickup pattern works. In a recording environment, people tend to prefer the image that's all the way on the left, the circle, which is an omnidirectional microphone. This microphone basically hears from all directions equally. That's not really true in practice. It hears higher frequencies coming from where it's pointed more strongly than from behind, but it does generally pick up sound from all around. So very awesome for recording applications because it means we actually pick up better bass in most situations. But for a live sound environment, not the right microphone, because any speaker that's pointed in any of the 360 degrees is going to be heard by this microphone and sent back to the other location. What we tend to prefer is the one in the middle. This, I don't think you can see my mouse, but this one here, the cardioid, called cardioid because of the shape resembling a heart. This microphone hears very well from the front and not very well from the back, and that's good for doing what we call acoustic echo rejection, which is basically ignoring everything from behind the microphone while only hearing what's directly in front of it. These microphones are susceptible to some other strange phenomenon. Most commonly, you'll encounter something called the proximity effect, which means if the microphone is placed very close to the sound source, there will be an artificial bump in the low frequency range. It can be a pleasing effect, but it can also misrepresent what it actually sounds like. So just something to bear in mind as you're setting up these microphones. While they generally tend to prefer to be close to the sound source, you need to be conscious of what it's doing to the quality of the sound that you're capturing. And then down on the far end, the ribbon microphones, which I mentioned before, kind of look at both the front and the back because of the physical characteristics of how that microphone is designed. There are some microphones, one of my favorites to use is oh my goodness, AKG 414, which is a very common condenser microphone that actually allows you to switch between polar patterns on the microphone itself. So they're good because they're very detailed and you can actually choose what type of polar pickup pattern you want. Once we have our signal coming out of a microphone, as I said before, it needs to go into a microphone preamp so that those very tiny voltages the microphone is capturing can be amplified into audible space for us. So you have two essential choices here, analog and digital mixing consoles. There are pros and cons to both. Analog consoles are rock solid. They're used in live sound, well, traditionally used in live sound a lot more than digital consoles, simply because digital consoles run on software with computers inside them and they crash. So the benefit of an analog console is a very simple, simply designed device that doesn't rely on any software in operation. And usually if there's a problem, it's a mechanical or electrical issue, which is typically easier to identify than something buried in software somewhere. The benefit of digital is you get a lot more in terms of processing capability. So while an analog mixing console, most of them, if not all of them, have equalization that you can do, digital consoles also have the ability to add other types of processing like compression, expansion, dynamic compression and expansion. There's all kinds of additional processing that they add, as well as the ability to save a configuration and quickly recall it. So they're both used, I don't know if equally anymore. Digital tends to be more common just because they're inexpensive and they're so powerful these days. But depending on your situation, you may prefer analog because of the simplicity of the device. We talked a little bit just now about the types of audio processing, but we don't tend to use a lot of these in live environments, live interactive activities like the ones we're speaking about. The compression, because, well, I'm speaking from my perspective as a classical music institution. We don't like to artificially modify the sound that much because we're working at such a high level. The coaches need to be able to trust what they're hearing and know that it's an accurate representation of the player. However, equalization is sometimes used, particularly if it's an instrument without a lot of low frequency information, to cut out everything on the super low end because that can cause rumble and feedback in that kind of area of the frequency spectrum. So depending on what you're trying to do, even in classical music, you may use something called a high pass filter just to remove any of that from a possibility. Compression may have an application for you particularly if you're using voice or speaking. If you're in the theater world, dynamic compression basically controls how loud a signal can get in comparison to how low the signal is. So what you do with compression is you set a certain threshold above which the signal is attenuated or automatically lowered. So it kind of takes the dynamics of the sound you're capturing and squishes it. So you have a much more control And if you're doing something like speech, where people may be talking quietly and you still want to be able to hear them, but then at other times they start shouting and it's too loud, that can help you control that range of dynamics if that's important to you. Expansion is the opposite of compression, meaning that if you only want to hear a microphone when there's active sound going into it, you can tell through your processing or mixing console, when the signal goes above this threshold, I want to hear it full volume. When it goes below this threshold, I want you to automatically reduce the volume so that I don't hear that microphone. There's also another variety of, or flavor of expansion called gating, which is basically turning the microphone off when it's not active. And then there's acoustic echo cancellation, which, you know, works sometimes, doesn't work for others. Like we said before, anything that resembles feedback in character, as far as a sound, like a pure sine wave like clarinets or flutes, tend to create situations for echo cancelers that are difficult to understand. So they don't know what to do. They'll shut off the notes. Latency is a hot topic, particularly for live performance. Processing adds delay. Now, if we're talking about audio processing, depends. Usually it's not a whole lot of delay. But it does add delay, and we're talking about, like I said before, there's a magic range of 40 to 50 milliseconds where anything past that point, it becomes difficult to play in sync with someone else at distance. So just know that when you add a compressor, or when you, EQ is not so bad, but when you add any of those dynamic processing, you do induce a little bit of delay. The delays are not enormous, but if you're, depending on how much processing you're doing, it can have an effect. Mitigating latency can also be done physically. So we talked about close miking. If we talk about close miking, that's generally how we prefer to set up microphones for these live interactive environments. The physical distance from the microphone to the sound source is added latency. So remember, 1 foot of distance equals 1 millisecond of delay. So if your microphone is 15 feet away from your sound source, you've already established that you're going to have a baseline 15 milliseconds of delay before it even gets into the device. So just know that. Near field monitoring. So just as there's a physical delay for sound getting into the microphone, there's a physical delay from sound coming out of a speaker and hitting your ears. So we'll look at a diagram a little bit later on, but just know that if you're in a situation like the one we have today, if I was participating in a class with somebody and there's an audience like you guys, we would probably want to have separate playback systems for both situations. So you have these speakers pointed at you, but I would probably want a monitor much closer to myself so that we're limiting the physical distance between that speaker and my ears so that we're not adding any unnecessary delay. It wouldn't make sense to have, like I'm sure a lot of you have spaces where there's speakers hung from corners of rooms or mounted on the wall, something like 20, 25 feet away. That's inducing latency physically. So just know that. It's generally better to have the speakers closer to the listener. To manage echo, one of the big things, and this is where EQ is helpful, a lot of rooms, especially this room or rooms like this room that are a rectangle with flat walls facing each other, there are particular frequencies which are emphasized naturally by the physical characteristics of the space. And I've been listening, I can't tell, but it sounds like there's some kind of low mid frequency in this room which is being amplified from where I'm sitting because it sounds really bassy for my seat. Might not be true. You can do all kinds of cool measurements to figure this out. You blast pink noise in a room with a specialized microphone and it gives you a measure of the frequency spectrum and it'll show you if there's peaks somewhere. So it's just good to know that because you can balance out both the sound for playback, so anything playing out of the speakers, you can try to balance or limit the effect of the room on the playback sound. You can also do that for your microphones to a lesser degree if you find that there's some kind of standing wave is what they're called, a particular frequency that speaks or is louder than others. Another way to effectively manage echo is to use close miking, even though it's not necessarily the audio engineer's most favorite setup. By putting a microphone closer to a sound source, you can reduce the amount of gain or volume the microphone needs to capture, and that helps to limit anything that's off axis from the microphone or pointed at the back of the microphone, which, like we talked about before, is essential. So please don't point speakers at the front of microphones. It happens all the time, and it's the most basic thing we can do to make sure we have clear, intelligible audio in these activities. For non-ideal acoustic spaces, you should use processing as your friend, equalization, compression even, expansion. Again, what should drive your decisions here are the needs of your application. So if it's educational, the person needs to hear a clear, consistent representation of what they're hearing. If it's a performance that an audience is enjoying, then you need to think more carefully about aesthetics and the enjoyment and pleasure of the sound. Those are bad terms, but I hope you understand what I mean. So this is a great concept that Jesper, which is the reason it's trademarked, is because I think the first time I heard it was in Jesper's presentation last year, is the concept of double acoustics, which is another thing to know, because especially in an educational context, when I capture sound in this room and send it to your room, wherever you may be, when it's played out of a speaker, you're not just hearing the acoustic of my space that I'm capturing on microphones, you're hearing the acoustic of the room it's being played back in as well. So you have to understand that, know what it's going to do going in so that you don't create, in most cases, a washed out sound that no one can really hear clearly through. Because when you add reverb and room presence 2 times, you're creating double the reverberation, double the acoustic information of the space. So it's just something to know. That's where near field speakers can be really helpful, because the more direct the sound coming from the speaker is for the listener, the more they're going to hear that actual signal versus the emphasis the room creates. So something to know as you go into setting these spaces up. Here's a very oversimplified diagram showing proper setup. And it's proper only in the sense that the speaker, which is represented by this icon, is pointed at the back of the microphone. So we're benefiting from that acoustic or natural echo rejection of the microphone and its characteristic. And I didn't put a camera on here, but another common issue with people who set these things up for the first time is they will place the monitor in this position, which is my favorite position, and then they'll place the camera over here. So what that does is every time I'm addressing the person on the other side, they're seeing me talk at them like this. And it's not good for maintaining any kind of conversation because it looks like I'm not talking to you. So please set your cameras up in front or up directly above your monitors or video playback systems. Here's the situation I described before, where in a situation where there's an activity and people are observing, whether it be a concert or an educational thing, there's 2 different setups we're concerned about here. One is the actual activity that's happening on stage, which has a separate playback system from the one that's meant for the audience, and that includes the display. So it's never really a good idea to, for instance, project a giant image like this and ask the participant, the musician or the coach who's participating, to use that as their monitor while the audience also uses it, because there's different needs between those 2 groups. The person participating needs a close monitor that clearly shows what they're seeing and is illuminated in a better way than projectors are traditionally capable of. Because we have a large audience, we need a large image for them to see. And it's just the physical, you'll see people, if you put them in front of a big projector, doing this because they can't capture everything they need to see without tilting their heads. So it's another physical consideration to keep in mind. And then separate playbacks, because we don't want the audience monitoring from the same speakers as the performer or student or teacher, because that means you're amplifying those speakers very loudly and the microphones on stage will hear them. It will create audio problems. Moving on to video, and it's going to get real boring here because we're going to talk about technical specifications, but I'll try to move quickly through these. Here are common video formats that we use that all of these tools incorporate in one way or another. SDI is pretty much the professional format that people use for video infrastructure. It's used in broadcast, capable of quite, well, not so substantial bandwidths anymore, and this is what's interesting right now, at least in regards to HD or SDI format, is how it is being used for 4K and high resolution video, because there's no established standard yet, and so there are different flavors of SDI depending on who makes the equipment you're using. So just an important consideration if you're looking at doing professional video infrastructure, it's pretty important early on to establish what your production format is, like what is the highest level of video you're going to be utilizing in your space, and then think through all the steps of all the equipment you're going to need that will require. None of these tools, except for UltraGrid and NVTP/Nimbra, use SDI signals. So you necessarily need to do conversion to get SDI into one of those solutions. HDMI, everyone knows it's a pretty common commercial video format. It is quite slow in terms of how it's processed, but it handles high bandwidths and is even capable of 4K in later iterations. DisplayPort is a pretty common one on computer graphics cards. It also does high resolution, supports higher frame rates than HDMI, as well as offers 3D, but HDMI can do 3D as well. Similar bandwidth capacity. DVI is an older, less common digital interface we still find on computer video cards. It was superseded by DisplayPort. Slightly lower bandwidth. All of those video signals are limited just in the length of cable you can use without any kind of amplification or repeater. So again, the benefit here, if you're looking at all of these, and you look at SDI formats in comparison to the more consumer level formats in HDMI, DisplayPort, DVI, and component even, the distance limitations you have of transmitting that signal over copper for SDI is much further. So it can go much further than any of these other formats, which is why broadcast utilizes it. So yeah, the benefits. SDI is a professional standard. There's plenty of equipment that accommodates it. It's uncompressed, so it's basically what you put in is what you get out. DisplayPort offers high resolution, and one benefit it has over HDMI is that you can actually output multiple signals through one cable. But again, we have a limitation on the length of that cable. HDMI is cheap, which is its big benefit. DVI is faster than those two previous signals, but it's limited in bandwidth. And component, because it's an analog standard, is obviously very fast. Like I said, SDI is expensive, so just know what you're getting into if that's your chosen institutional baseline. Everything else except for DVI and component is quite slow, so just know we're talking about not only does the display add delay when we're using something in Lola, for instance, of something like at least 12 milliseconds, but HDMI and DisplayPort will also add delay on that output. So every bit of delay you add to the video signal is going to impede that sense of immediacy or real time. Even though they're imperfect, let's talk about displays. So traditional big flat screen TVs, the latencies typically go from 14 to 68 milliseconds, which is okay. However, OLED, which has been a common technology or a preferred technology of late for these types of displays, is generally slower. So we prefer to use LCD monitors, and there's a great website on the next slide, displaylag.com. This is a group of mainly gamers who do these real-world latency measurements for displays. So if it's important that you're using the fastest display available in the market, that's a good place to look. All of these displays work fastest when you're using native resolutions of the display. So what I mean by that is whatever device you're connecting to your monitor, the resolution that device is outputting should match the native resolution of the display, because whenever the display is asked to process the signal, that adds additional latency. So for LCD monitors, you're generally looking at 9 to 112 milliseconds. So be careful about which ones you choose. There's also a lot of misinformation about refresh rates. So refresh rates are not the same as frame rates. And the advertised frame rates for some of these monitors are for particular situations and types of video signals, not necessarily just plugging a device into the back of it. So again, I would direct you to this DisplayLag website, which will give you true real-world latency measurements, which is most important. Projectors are terrible, but they're a necessity in this space. So on the best situations we've had, we get about 18 milliseconds of delay. That's generally when you're using analog inputs, which who uses analog inputs anymore? And again, native resolutions are important for limiting the amount of processing that happens in the projector itself. So which display should you use? The old school CRT television. And let me see if I can pull up this video, because this one doesn't require sound. Hold on, let's, even though it has sound. Let me get out of this presenter view.
You gotta do what? I gotta believe.
Am I on an extended display? What did I do? Oh, okay, good, you can see. So this is a CRT, sorry about that, CRT side-by-side with a more conventional HD TV, and you can mostly see it when the frame refreshes or the perspective changes. You'll see the monitor on the left changes ever so subtly before the one on the right. And that doesn't seem like a lot, but that's about a frame of delay, which is at, let's see, this is probably 2997. That's about 30 milliseconds. So that's how fine we're talking about in terms of latency and the need to minimize it as much as possible. One frame is 30 milliseconds at this frame rate. So it is a perceptible difference. And when you multiply that by a round trip with a live situation, you start to experience this thing where someone will go to play a note and you'll hear it before they actually draw the bow across the instrument. And it's just, especially musicians who are kind of attuned to like notice the subtleties of something like that, they'll be like, why is the sound behind the video? And one of the major reasons is likely the display that you're using, not necessarily the communication solution. Okay.
That's a big question.
Yes.
So how do you connect the most modern gear to the old?
It's difficult. It's difficult. So the best way to do it would be a hardware-based converter that would convert a more conventional digital signal to an analog format. Yeah, but you know, it depends. You know, like it depends. So some of the higher-end video processing companies, like Asia, is a common one. The more you spend, the faster it is. Blackmagic is not going to be very fast. It's cost effective, but it's not going to be very fast. Most of them will measure it by frame, so Blackmagic is usually at least a frame of delay, which defeats the purpose. It's complicated. I only bring this up to demonstrate the fact that old technology is better than new technology in some capacities. Let's see. Last. Ooh. Yeah, I figured maybe. Yeah, okay. Last up is lighting, and I am not a lighting engineer. So I stole this information from other people, but generally in an environment where you are using a camera capturing for broadcast or any kind of interactive activity like ours, subject needs to be well illuminated. It's not a pleasing experience to look at someone if they've got, raccoon eyes, because there's a top-down light that's just creating all these shadows on their face. It makes people look ugly. No one wants to interact with ugly people. It also helps separate the subject from the background. If you're shooting, white on a flat wall, it creates this really weird two-dimensional kind of image that is not aesthetically pleasing. And although aesthetics are not necessarily our primary concern, one thing that we need to keep in mind is that the people participating in these activities are humans and they want to feel comfortable in the environment. So seeing an image that is well lit, that is clearly defined, that sound that is clearly intelligible and easy to hear, it's essential, because otherwise it's going to negatively impact what's happening. So for lighting, typically a baseline setup for lighting involves 3 lights, and it's known as 3-point lighting. Key light, which is basically the front-facing light that does the general illumination of the subject. A fill light, which is kind of off-axis or at an angle from that key light, and then a backlight, which is primarily meant to create separation between the subject and whatever's behind them. So there's a simple diagram which shows a basic setup for 3-point lighting technique. These things change from situation to situation, so there's not a turnkey solution like for many of these things we've talked about. Grab your lights, move them around. And that's the same with microphones. Move your microphones around, see where they behave better, see where they accurately capture or show whatever it is you're trying to show. There's no perfect solution. Anyone tells you there's a perfect solution is wrong. And that is audio, video, and lighting in 30 minutes. I'd be happy to answer any questions. Otherwise, it's almost lunchtime. Any questions? So yes, for instance, the Polycom echo reduction software or function basically does an analysis of the incoming audio signal and does a phase inversion, and it measures the delay of the output signal and then tries to basically acoustically cancel out the audio, if that makes sense. So these are totally imperfect solutions though, because what you'll find is echo cancellation, when the processing affects the audio, it not only takes out the echo, but it will remove that part of the frequency spectrum from whatever your incoming signal is as well. So it's an inelegant solution, but it is a means to an end. And it's not, yeah. They do. I've never personally used it. I would take all of those claims with a grain of salt, though, because knowing how their echo canceller behaves in their flagship room systems, it may be subtly better. But again, in Polycom, most of those H.323 manufacturers, when they make those marketing claims, are focused primarily on their intended use, which is speech and meetings most of the time, traditional just talking head situations. So they're not necessarily focusing on full frequency spectrum audio in the case of a musical performance or activity. So it may sound better. I've not personally used one. If anyone is more familiar. Mm-hmm.
You can turn off data cancellation as well.
Mm-hmm. How much? Do you know how much it costs?
No, it's on all the old models.
Oh, you're talking about the Siren audio codec.
Yeah.
Oh yeah, okay. So Iron, that's the compression format, which does sound good, but it does affect overall frequency spectrum very much so in the low end. So there's almost no, below 100 hertz, almost no frequency information that's transferred. And even in the high end, there's a big roll off, I think above 14 kilohertz. So like the airiness and the very like high and low detail in sound, even with that format, is lost. And it's also, there is some level of dynamic compression that happens. It's subtle, but you can, like if you have, and we've done this before, where you have a Polycom setup side by side with Lola, you can tell almost immediately that there is a subtle loss in dynamics and overall spectrum. Mm-hmm.
That was a demonstration we did once from Yale University to
Mm-hmm.
the World Symphony, and we had 3 different scenarios with the exact same musician, the exact same speakers.
I think the same capture devices too. It was basically all
Yeah,
the same.
And it was really interesting to get to hear the difference.
Mm-hmm. All right. Well, thank you everybody for your attention. I hope you enjoy the rest of the conference. Again, thank you for being an overachievers.